In this video, I'll be showing you how to output data to Amazon Athena using Upsolver. Let's start with a simple example. This is a table in Amazon Athena that I created using Upsolver. My data source is a stream of users voting on their favorite superheroes on a website. The events were sent directly to Upsolver via HTTP, and now I want to be able to run SQL queries on them. Amazon Athena is a relatively new and powerful AWS tool that allows you to easily run SQL queries on your data in S3. It uses Presto as the underlying engine and does not require any infrastructure setup at all. You don't have to pay anything to put data into Athena, since it just reads it directly from your S3 bucket, and querying data only costs $5 per terabyte read. Keep in mind that if you're using a columnar format like Apache Parquet, terabytes read can be significantly less than the size of your files in S3. Let's take a look at our table. This is the result of a simple select star. We can see that there are 8 columns. The first 5 are data columns, and the year, month, and day columns are partition columns. Athena runs all queries as full column scans on partitions of data, so adding these columns to the where clause will reduce the cost of a query. Let's see how many rows are in our table. Queries in Athena scan the S3 files directly, so any file added to the proper directory will immediately show up in query results. We can see the results here. Now let's check how big our table is. To do that, we'll need to run a query that uses all the columns in the table. That's the size of the entire table, and would reflect the cost of a full table scan. If we were using a format like JSON or CSV, this would be the cost of any query, since these formats don't allow only reading specific columns. Now let's try to query just the country column. We can see that the data scanned is much lower than the size of the table. Data in Parquet is compressed per column, so columns with very few unique values will take up very little space. If we try querying the user column, we can see that the data scanned is much bigger. This is because this column has many different unique values that are also longer than the countries, so they compress less effectively. Now I'll show you how I created this table. First of all, we need to make sure we have the correct permissions to write and read to Athena. Writing to Athena is just like writing to any bucket. I created a bucket for this demo, but you can also use an existing bucket if you want. We need a user that has access to Athena and to the data bucket we're going to use. I created a user called Athena Access for this demo, and I granted it the Amazon Athena Full Access AWS Managed policy, as well as full access to the bucket with this user-defined policy. Now let's add connections to Athena and S3 with this user. In Upsolver, I'll go to the Connections page. Then I'll click the arrow and select Amazon Athena. We need to go back to the IAM page to create an access key to use in this connection. We also need to configure the Athena Query Results bucket. I'll just grab the default results bucket from the Amazon Athena console. We also need to configure the region and give it a name. Now I'll create the S3 connection. I'll create another access key to use in this connection. We could reuse the same access key if we want, but I find it's better to use each access key in only one context. Don't worry, after setting up these connections for our first Athena table, we won't need to do it again. Now let's create our table. I'll go to the Data Sources page and select the superhero voting data source. Then I'll click the arrow and Add Output and name my output. We won't be aggregating the data in this demo, so I'll just uncheck this box and select Athena. The connection we just created is automatically selected. We have to pick the database in Athena. We'll pick default here. Then we name the Athena table this output is going to create. Now we select the S3 storage that we just created, and we're done configuring the Athena table. Now we can add our data to the table. Let's add the country, user, superhero name, universe, and time fields. Time is an auto-generated field that exists in every record in Upsolver that represents the time the event was ingested. While Parquet does support nested and array values, Presto works very sporadically with them, so Upsolver will automatically flatten the outputs to Athena for you, similar to how you would expect data to be flattened for a database or a CSV file. Now that we've finished defining our table, we can look at a preview of the data, and now click Run. Once we deploy, the table is created and populated for us. If we go back to the Athena console, we can see that the table was already added to the catalog, and data has started streaming into our new table. In summary, in this video we've covered creating an Amazon Athena output in Upsolver. Upsolver does most of the work for us, so it's really just a matter of deciding what data we want in the table, and all the data management is handled for us. This is by far the fastest and easiest way to get up and running with Amazon Athena for querying your data in S3. Thanks for watching!